Welcome back to the Stars and Beyond. In our last episode, we explored the mighty Sun, the star that powers life on Earth and forms the heart of our solar system. We delved into its history, its significance for our existence, and its potential future. Today, we turn our attention to the innermost planet of the solar system, Mercury. This small yet fascinating celestial body is full of mysteries and extreme contrasts. Together, we'll uncover its unique role in mythology and science, explore its geological features, and discover what makes it such an extraordinary target for space exploration. Let's dive into the world of Mercury, a planet of secrets and wonders. Mercury, the innermost planet of our solar system, has captivated human imagination for millennia. In antiquity and the Middle Ages, its significance was deeply rooted in both astronomical observations and symbolic interpretations. In antiquity, Mercury's elusive nature made it mysterious. Its orbit so close to the Sun renders it visible only during twilight, leading ancient civilizations to perceive it as both a morning star and an evening star before realizing it was the same object. Babylonian astronomers, known for their meticulous planetary records, referred to Mercury as Nabu, named after the god of wisdom and writing. This connection highlighted Mercury's association with intellect and communication, a symbolic meaning that persisted through later cultures. In Greek and Roman mythology, Mercury was associated with Hermes and Mercurius, respectively. Hermes, the messenger of the gods, embodied speed, intelligence, and the ability to mediate between different realms. These qualities were also attributed to the planet. Mercury was seen as a swift celestial body, delivering messages across the heavens. During the Middle Ages, a period when astrology and astronomy were deeply intertwined, Mercury gained even broader symbolic significance. Medieval astrology assigned specific attributes and influences to each planet. Mercury was linked to intellect, logic, and communication. It was believed that Mercury's influence was particularly strong in scholars, writers, and merchants. This notion also found expression in medieval alchemy, where Mercury was considered one of the primary archetypal substances, symbolizing transformation and change. Religious and philosophical interpretations of Mercury also emerged. In Christian symbolism, the planet was occasionally seen as a bridge between the material and the spiritual worlds, a concept that might have influenced the idea of Hermes Trismegistus in the Hermetic texts. Mercury, the innermost planet of our solar system, is a fascinating celestial body with unique features that set it apart from all other planets. But what truly makes Mercury so special? First, Mercury is the smallest planet in the solar system, with a diameter of just about 4,880 kilometers. This makes it smaller than some of the largest moons, such as Ganymede or Titan. Despite its small size, Mercury has an exceptionally high density, the second highest in the solar system, after Earth. This density suggests that Mercury has an unusually large iron core, making up about 85% of the planet's diameter. Scientists theorize that Mercury was once larger, but violent collisions in the early solar system stripped away much of its outer layers, leaving behind its massive metallic core and a thin rocky crust. Another fascinating feature of Mercury is its extremely slow rotation. Mercury takes about 59 Earth days to complete one rotation on its axis. But that's not the most surprising part. Its orbit around the Sun takes only 88 Earth days. This results in unusual day-night cycles on Mercury. A single Mercury day, meaning the time from one sunrise to the next, lasts 176 Earth days. This means that a year on Mercury is shorter than a single day. Mercury's surface tells a story of intense bombardment. Its entire surface is covered in craters, similar to Earth's moon. One of the most striking features is the Caloris Basin, a gigantic impact crater approximately 1,550 kilometers in diameter. It's one of the largest impact basins in the solar system. Surrounding this basin is an area known as chaotic terrain, likely formed by shock waves from the impact reverberating through the planet. Mercury's proximity to the Sun is another remarkable characteristic. It is located only about 58 million kilometers from the Sun, less than 40% of the distance between Earth and the Sun. This proximity results in extreme temperature variations. During the day, temperatures can soar to 430 degrees Celsius, while at night they can plummet to minus 180 degrees Celsius, making Mercury one of the most extreme environments in the solar system, where life as we know it is impossible. Despite these harsh conditions, Mercury holds surprises. Scientists have discovered water ice deposits in the permanently shadowed regions of its polar craters, a remarkable finding that shows valuable resources can exist even in the most inhospitable parts of our solar system. Another unique feature is Mercury's magnetic field. Although it's only about 1% as strong as Earth's, its existence is remarkable for a planet so small and old. Researchers believe that Mercury's dynamic iron core remains active, generating this magnetic field. When we talk about Mercury's surface, we are stepping into a landscape defined by extremes, a kind of cosmic canvas that has recorded the history of the solar system over billions of years. Mercury's surface is unique, offering some of the most fascinating geological features in the solar system. Let's take a closer look at the details. The most striking features on Mercury are its countless impact craters. Without an atmosphere to protect it, Mercury's surface has been shaped by billions of years of meteorite impacts. Much like our moon, Mercury displays what is known as a crater-saturated surface. This means that new craters frequently overlap older ones, creating the dense cratered landscape we see today. Among these, the Caloris Basin stands out as one of the largest impact basins in the solar system. Spanning about 1,550 kilometers in diameter, it's so vast it covers an area roughly the size of Western Europe. The impact that created this basin was so massive that it generated seismic waves which traveled across the planet, forming a chaotic, rugged terrain on the opposite side, known as the antipodal chaotic terrain. This region features bizarrely shaped hills and valleys, likely caused by those seismic waves reverberating through Mercury's interior. Another remarkable feature is the system of scarps, also called lobate scarps. These long cliffs stretch for kilometers and are the result of Mercury's core cooling and shrinking over time, causing the planet's crust to contract and buckle. Some of these scarps are up to 3 kilometers high and hundreds of kilometers long. This indicates that Mercury is still tectonically active, a rare trait for a planet so small. Mercury's surface also showcases extensive plains formed by volcanic activity. These smooth plains consist of solidified lava that once flooded the surface. Notable among these are the intercrater plains, flat regions between impact craters, and the highland plains shaped by earlier volcanic episodes. This highlights the significant role volcanism played in shaping Mercury's surface, particularly in its early history. Another intriguing feature of Mercury's surface is the presence of hollows. These unusual, shallow depressions are often surrounded by bright, reflective material. Scientists believe they are formed by the sublimation of volatile elements released from Mercury's crust. However, the exact nature of these hollow formations remains a topic of intense research. The exploration of Mercury is one of the greatest challenges in space exploration. Its proximity to the Sun not only makes it difficult to reach, but also poses extreme technical demands on spacecraft. Let's take a detailed look at all missions to Mercury and their objectives. The first spacecraft to visit Mercury was Mariner 10, launched by NASA on November 3, 1973. It first reached Mercury on March 29, 1974. This mission was the first to use the gravity assist technique, utilizing Venus's gravitational pull to adjust its trajectory. Mariner 10 succeeded in photographing about 45% of the planet's surface, revealing a heavily cratered landscape similar to the Moon's. It also discovered that Mercury has a magnetic field, a surprising find for such a small planet. These results largely fulfilled the mission's objectives. Several decades later, the second mission to Mercury followed. Messenger, Mercury's surface, space environment, geochemistry, and ranging. NASA launched this mission on August 3, 2004, and it reached Mercury on March 18, 2011, after multiple flybys of Earth, Venus, and Mercury itself. The third and most advanced mission to Mercury is BepiColombo, a joint project by the European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA. The spacecraft was launched on October 20, 2018, and is expected to reach Mercury in December 2025. Equipped with cutting-edge technology, including heat shields, ion propulsion, and precise instruments, BepiColombo is expected to unveil new details about Mercury that were previously unknown. Mercury might appear to us today as a geological relic, a silent time capsule from the early days of our solar system. Yet, even Mercury is subject to long-term changes governed by the forces of physics and the universe itself. Let's take a closer look at what the future might hold for this smallest planet in our solar system. Mercury is largely geologically inactive. Most volcanic activity ceased billions of years ago, and there are few signs of tectonic or volcanic processes today. Erosion on Mercury primarily occurs through impacts from meteoroids and micrometeoroids. Additionally, the solar wind, which strikes Mercury with intense force due to its proximity to the Sun, contributes to the slow transformation of its surface. Over millions or even billions of years, Mercury will likely continue to accumulate craters as new impacts occur, and older ones degrade. However, compared to planets like Earth or Mars, the geological evolution of Mercury will remain minimal. Mercury's orbit is one of the most fascinating aspects of its dynamics. Due to the Sun's strong gravitational pull and interactions with other planets, particularly Venus, Mercury exhibits signs of what is called chaotic dynamics. This means that its orbit could become unstable over billions of years. Simulations suggest a small but non-zero chance that Mercury could eventually be ejected from its stable orbit. In such a scenario, Mercury might either fall into the Sun, be expelled from the solar system, or collide with another planet. While these outcomes are improbable, they are intriguing from an astrophysical perspective. A critical factor in Mercury's future is the Sun itself. Currently in its main sequence phase, the Sun will expand into a red giant in about 5 billion years. During this phase, the Sun's outer layers will expand significantly, potentially reaching near Mercury's current orbit. If this occurs, Mercury could be engulfed by the expanding Sun. Even if it is not swallowed, the extreme heat and radiation from the red giant phase would completely alter Mercury's surface. Any ice at the poles would vaporize, and the planet's outer layers might be stripped away. Mercury, the innermost planet of our solar system, presents a fascinating but challenging target for amateur astronomers and astrophotographers. Its proximity to the Sun makes it elusive, but with the right techniques and timing, remarkable observations are achievable. Let's dive into how to successfully spot and photograph Mercury in the night sky. Mercury is one of the most difficult planets to observe due to its close proximity to the Sun. It always stays near the Sun and is visible only during short windows at dawn or dusk. Furthermore, it often appears low on the horizon, meaning atmospheric turbulence can distort the view. The brightness of the twilight sky adds another layer of difficulty. If you're observing Mercury with the naked eye or binoculars, here are some practical tips. 1. Choose a site with an unobstructed view of the horizon, away from city lights. 2. Observe shortly after sunset or before sunrise, when the sun is just below the horizon, but the sky is not completely dark. For your safety, never look directly at the sun, especially with binoculars or a telescope. This can cause severe eye damage. For astrophotographers, Mercury's small size and challenging twilight conditions make capturing it a rewarding endeavor. Here are some tips. Camera and equipment. Use a DSLR or mirrorless camera with a telephoto lens, at least 200mm focal length, or a telescope with a camera adapter. Exposure settings. Mercury is a bright point, so short exposures between 1/50th and 1/200th seconds at ISO 100 to 400 should suffice, depending on the twilight brightness. For advanced photographers, recording video with a planetary camera and stacking frames can yield impressive results. This was our fascinating journey to Mercury, the smallest and closest planet to the Sun in our solar system. We explored its mythological significance, unveiled its extraordinary characteristics, and looked at the scientific missions that brought us closer to understanding Mercury. But our adventure through the solar system continues. In the next episode of To the Stars and Beyond, we'll turn our attention to Venus, a planet that dazzles with its radiant brightness and intrigues with its mysterious, dense atmosphere. What makes Venus so unique? Why is it often called Earth's sister planet? And what secrets lie hidden beneath its thick clouds of sulfuric acid? Find the answers to these exciting questions in the next episode. Thank you for joining us on this journey. See you next time on To the Stars and Beyond.